All right. Last presentation, and thank you, Thermon, for being the last guys, but it's one of our sample line providers that we use a lot. So we wanted to make sure that they had an opportunity to give their spiel and talk about what they had to say and how they make their lines and what's going on, because we use Thermon lines quite a bit. And I've known Derek for a long time. He is much younger than I am, so he was just a wee lad when we met. But anyway, Derek, take it away.
All right, appreciate you guys hanging around for the last talk. Heated sample lines. I think you guys heard 3 others before me talk about sample lines, so I only have 100 slides, so bear with me. I'm just kidding. I'm not going to go over most of the stuff that Scott went over yesterday. He did a really good job explaining designs, and he gave you an overview of heat tracing. There's a ton of heat tracing options out there. What I do want to focus on is how we differentiate ourselves from O'Brien. They're our biggest competitor in the marketplace. The one thing I will say, you can't say anything bad about them. They use Invent heater cable. We use our own Thermon heat tracing. Those two are the best in the business. Heat tracing is kind of the heart and soul of umbilicals. So as long as you have a good heater cable in it, you should be good to go. Wrong way. To the bar. All right, I'm going to start just talk about a little bit about what Thermon is, who we are. We're not just an umbilical manufacturer. That's a small portion of our business. Give you an update on lead time, supply chain issues. I don't know if I heard Scott talk too much about that, but I'm sure we're kind of seeing the same thing. And talk a little bit about design, but build considerations, and then I'm going to kick it over to Nathan for a slide. I talked him into going into our controls and monitoring type stuff that we have. We have some software. And then John Mattingly is going to come into talking about installations and accessories that we have. I skipped over the introductions. I got a team with me, John Mattingly. He's a business development manager, focuses on power industry. You guys with Calpine are probably real familiar with winterization projects that you've been doing with us for the past couple years or last year. Nathan's our regional sales manager out of Salt Lake City. He's relatively new with us, doing a great job. You'll hear from him in a little bit. Talk about Thermon overall. We got started in steam tracing back in 1954. They moved over into electric heat tracing, started making controllers and building electrical panels, and moved into the analytical instrumentation bundles in the early 90s. So we've, for the longest time, we've been a tracing company. We purchased a company in 2016 that did heating systems as a company out of Canada. So now we're a process heating company where we have environmental heating, like the electric air heaters, gas catalytic heating, immersion heaters, and then most recently we purchased a company called Power Blankets. That's kind of interesting for this field. It may have a role in some gas cylinder heating. But like I said, we're going to focus on the umbilical side of things today. I wanted to put this up front. I'm kind of proud of what we've done in the past couple months. If I would have been standing up here last year at the same time, I wouldn't have had a lot of good things to say. We were struggling in the labor market in San Marcos. There's a ton of industry moving there. So a lot of the talent we were getting, they'd leave for a quarter more an hour. So what we did on site in San Marcos is we revamped our whole pay scale. And ever since then, we've gotten lower turnover rates. I mean, it's been really nice. The biggest thing we did, though, is we hired in the bundle facilities, we hired a new production manager, a scheduler, and a new supervisor. And those guys are all stars, to the point where our lead times last year were 17 weeks, sometimes longer. Some of that was supply chain issues, and some of it was labor. But from what they've been able to do now, they're asking us for work, and we have more capacity. So, I mean, we feel like we're selling enough, like our goals are being met, but these guys are are doing a great job. Now, that being said, the supply chain issues aren't gone. We've just been able to stock up on stainless steel tubing. If you go to the mills right now, I know Handy Tube is booked through March of next year. Sandvik is kind of getting back in the business. The Korean tubing mills have already shipped all the stainless steel they can ship to the US this year. So if we either have the tube, O'Brien has a tube, or distributors around the country are buying tubing up. So we're having to go and buy tubing from them if we run out, or we're getting in line and getting tubing next April. So it's a pretty tough market, but like I said, we're heavy in inventory right now. Corporate doesn't like it that much, but that's kind of the situation we're in. We're having problems with silicone. It doesn't really affect you guys. We make a product that we put silicone over. We're just getting allotments every month. It's getting backed up pretty good. Some of the heater cable components have been hard to come by, but those mainly stem back to nickel, which goes along with the stainless steel. So anything with nickel in it, we've had issues with. And then PFA is new. We use PFA in our heater cables, and then we use PFA tubing, FEP tubing. Usually you could get tubing in a couple weeks, but it's been pushed out to 8 weeks now. We've had manufacturers that we buy virgin material from, like Solvay, they got out of the business. So we're going to find new vendors for PFA, and there's not a ton of people out there, right? So that could become an issue moving forward. And then just to look at the lead times, these are the best we've ever had for lead times. That's why I wanted to show them. CEMS bundles, we can do 4 weeks. If we have the material, we can get it out in a week or two. Shouldn't be an issue. All right, getting into design. You guys heard this yesterday. We're looking at the maintained temperature while looking at the lowest ambient temperature. We also don't want to overheat the fluid and make sure we're not getting that outer jacket temperature above a touch safe of 140 degrees F. So those are kind of the things that we look at from an overall standpoint. So when you go into the considerations and we're asking for an RFQ or Bob sent us in an RFQ, he's pretty good about it. They send us in a drawing. It's got everything we need on it. We rarely have to come back with any questions, but there's always the tube material, size, treatments. The links are important for sure. Operating voltage, hazardous area classifications and CEMS, it's mostly GP, but we do have all the classifications with our heater cables. We have a group of guys in R&D that work on certifications and standards. We're actually a certified testing facility, right, in San Marcos for CSA. Yeah. So when we do our research or whatever, they can come on site and test the bundle or the heater cable there. Maintain temperature, ambient conditions, obviously. The max process exposure temperature is a big one. You don't really see it in CEMS because the gas loses the temperature really quickly, but in power plants, the steam sample lines for sure. The picture we showed earlier was actually a buffer design. We got to move the heater cable away from the tubing to make sure it doesn't melt that PFA. And other things to consider, the sensors, alarm wires, power wires, whatever else you need, blowback, calibration tubing. So once we get all that information, what we do and what's unique about Thermon is that we have our own software that has all the information from our heater cables that we've done from R&D over the years. And they put it into some software, and we put all that information in, and it spits out this report. And what's neat about the report is that it shows a lot of information about your heater cable, whereas you may be maintaining 300F at -20. Where's the voltage? At 220 volts. But to get to 300F on the hottest day, that heater is going to get to 393F. Well, say this isn't GP and it's a class 1 div 2 T3 rated area, right? Well, T3 is 392. What this software will do is say, nope, you can't do that. You need a controlled design. So it sets a high temperature alarm so that we make sure that heater cable doesn't violate that T rating. So that's kind of something unique that we have. And it's nice to, go ahead.
Any bundle that's operating at those temperatures on a stack, they're not going to be T3. I don't care what they say. The plant might be T3,
Well,
No
yeah,
way
because it's
in
up
legally
top.
that stack can be in a T3 area. The exhaust gas is way too high. So they normally exempt that stack out of that area
Which,
classification.
which we know that in the US, but we're fighting it in the Middle East right now where stack temperatures are high and they're telling us that it's a T rating and we're like, no,
Yeah.
there's no way you can do that. It's just not possible. All right, to go into our heater cables, I didn't list all of our heaters, like, the types that you saw yesterday. What I'll say is, as far as constant wattage goes, we do use our MIQ heater quite a bit. We manufacture it in Canada. The Canadians love to use it, I think, because they manufacture it up there. But it is not cut to length. We use it when the exposure temperatures are high and we can't use the cut to length polymers. To go back to our self-reg, this is our low temperature polyolefin based self-regulating cable. You guys saw the curve yesterday on what self-regulating does. It essentially cuts itself off as it heats up. This one, the main thing is you don't want to use it if your tube temperature is going to get anywhere above 185 F, you're going to damage the cable. It's polyolefin based, so it's going to melt and it won't work. But if it is going to get up above those temperatures, we have other options. HTSX is one of our options. We also have VSX and a newer cable, USX, which they all kind of operate the same way. And we use those in bundles some. The main one we use in our CEMS, though, is our HBT. It's our power limiting cable. It's what I call the Cadillac of CEMS cables. You can get up to 375 maintain. I know here it says 410, and that's where you got to be careful. I saw yesterday there was some like 455 temperatures on the heater cable. Those are heater cable specs on a pipe. When you're in a bundle, you get one pass, and you're going to overheat that cable. In fact, you're going to overheat that cable if you try to get it to 410. So I know from our heaters, the max you can do is about 375 in a bundle comfortably without. I mean, we have some that you can push the limits if you want to, but that polymer starts to soften, and you don't want to do that. To highlight the HBT a little bit more, just so you can see kind of how it's built. So what we do and what the component that we've had issues with is this element that's coiled around this right here. So this is like a spring-like coil. That's what's heating up. So that touches the conductor on the nodes, like he spoke about yesterday. And so we know how much coil is in between each node. We know the resistance and hence the power output. This cable right here, though, I worked in R&D for 9 years before I came over into the bundle group and did return material analysis. And I saw some HBT come back, but it was always off a pipe. Somebody was doing maintenance. They'd rip it off the pipe, not knowing what it was. And they'd, somebody would tell me what happened to the heater. I'm like, I don't know. I wasn't there. But I never saw any come back in a bundle because it's protected by the insulation, right? So, I mean, this stuff will last. I heard somebody talk about 15 years. I mean, as long as it's dry and it's in a bundle, it'll last as long as the tubing lasts. So it's pretty reliable. Tubing, you guys heard about tubing yesterday. I talked about it a little bit earlier. We stock in all sorts of flavors of it. Wall thicknesses, sizes. We're stocking treated tubing to save on lead time. You don't see a lot of that in CEMS. But if you come to our shop, our walls are lined with it. PFA. The question yesterday about permeability. One option we have is a high purity PFA, and we do see that being used in the hot bundles for mercury, and it does help, I think, a little bit on the interference that you're getting. And the last thing I got for you guys on kind of what differentiates us from O'Brien, they do theirs in kind of a flat pack. It's worked for them for years. They'll tell you why they do it that way. We do ours in a spiral arrangement where we have these big capillaries, capstans that spin our tubes and heater cable, so that we have, you can bend it in any plane. You get a better thermal performance as the heater cable is being spiraled around all the tubes. So it's a pretty neat thing to see. So if you're ever down in Texas, holler at us. You can come to check out the shop. Now, Nathan, you volunteered.
Yeah, thank you. I probably don't need a mic. You can hear me in the back?
It's just for recording
need it for
purposes.
recording.
No. Talk softly. I need to
Yep.
go in the box
You'll
too.
be good. Yeah, we do.
Oh
Sorry.
man,
All
I thought
presenters
this
in
was
the
gonna
box.
be easy. All right. Okay. Hello, you can still hear me in the back?
Yep.
Okay, am I positioned right?
You're
We
good?
good?
Yeah.
Okay. Nathan Ehresman here. I'm a regional sales manager with Thermon. I've been with the company about 1 year and 2 months. But I begged Derek for just 5 minutes on controls. I've been doing process heat and controls for 20 years. I'm a controls geek. I love controls. And if you ever want to, 5 o'clock, couple of beers, talk about controls, I'm your guy. I tried that on match.com and it didn't work. I don't know. So I have been to countless power plants, and I'm taking a tour with an I&E manager or a facilities manager, and there's a bunch of heat trace either in a tubing bundle or on a condensate return line or process line, and it's going back into a panel, and the panel's an alarm. I'm like, guys, do you know your panel's an alarm? Oh yeah, that light's always on. I don't know what it's all about. Really? Because when that condensate return line freezes and your power plant goes down and there's a brownout and people are going to be asking questions, they're going to wonder why that alarm wasn't taken care of, right? Like you have to know this. It has to go somewhere. The signal can't just die in a box. And they sort of mutter and murmur, and then we all move on. So point 1, controls. Point 2, if you have a power plant, and I've seen this a number of times where there's a required PM, and that required PM says someone has to go out and look and make certain that heat trace is on, so we don't have the aforementioned scenario. And I was in a plant in not quite a blizzard, but it was not nice. It was bad conditions. And there's this poor guy who's putting on, the snowsuit, and he's going out on the catwalks looking to make certain those lights were on, looking to make certain that there wasn't any alarms on the control panels. And I'm sitting here warm and dry and toasty in the control room, feeling a little bit bad and going, we can help with that. We have a solution here. Can I please talk to you about a SCADA, a networked integrated solution that we can provide? So between the alarms not going anywhere and these poor folks that are going out in blizzard-like conditions looking at heat trace, and then the third point, and it all ties together here, the third point is you have folks retiring every single day that have decades of experience. You have new folks coming up, hopefully, that don't know anything because they're new. And so we're, as an industry, we're experiencing this tremendous brain drain. And the solution to that, we're all being asked to do more with less. The solution to that is automation and SCADA integration. And that comes back to controls. So a heater, heat trace, they're phenomenal products. We make great heat trace. Competition makes good heat trace. It's just a resistor. If you don't have the controls, if you don't have the brains, the resistor really doesn't do very much. So we have control schemes that, number 1, are smart. You can talk about energizing the cable at programmed intervals, pulling an amp draw, putting that into a trend line, and then looking at that trend line over time and making certain the health of your system is appropriate. We have SCADA integration where it can bring smart alarms back into a control room. We can integrate that with Power BI and a Microsoft SQL server, so you can have reports that are logical and easy to understand as opposed to just an alarm light. These are all differentiators that truly are helping power plants across the country operate more efficiently. So that's sort of my thing on controls. Like I say, I'm a total geek. If you want to talk about I/O and Modbus mapping and all of that, I'm your guy. Anytime, I'll be here all day. So that's that. Lights. If you're not going to get a control system, at least get a light. They go on the end of the cable. They're good for tubing bundles. They're good for analyzer lines. They're good for any other heat trace line that's in your plant. It'll tell you that there's voltage at the end of the run. It's a feel good, right? It doesn't mean the cable is working. It doesn't mean your amp draw is appropriate. It doesn't mean any of that, but it's better than nothing. So if you take one message away, wireless communication, SCADA integration, really, really critical. If you take 2 messages away, if you're not going to go that route, at least please get a light. So that's it. Yes, please.
Question is, speaking of controls, I don't understand mine. I mean, I've learned a lot the last couple of days, but I mean, so I understand what they do. Is it controlling to a certain temperature, or is it just on or on?
Right. Yes. So.
And then further on that.
Uh-huh.
cycling the motor. And
Right.
that preserve the height of the-
There's several schools of thought on that, honestly. And there's a couple of questions nested in there, so I'll dissect them. Number one, it's always better to have controls than not have controls. So that's the first thing. It's going to save you money. I'm working with a lot of oil and gas companies, and we have to kind of be cautious because they're oil and gas companies, but they all have green initiatives. So we have these conversations about, hey, can you help me be more green by controlling my heat trace? Therefore, I'm using less energy. Therefore, I'm more green. And I'm like, you know, you're a drilling company, right? And then we sort of say, yeah, okay. But so yes, it's always better to have controls, and it's always better to modulate that as opposed to not modulating it. From an energy consumption standpoint, primarily, it's not going to hurt the trace. You're not going to have rapid fluctuations in power. So if you go to a light switch and you go like this on a light switch, are you going to exhaust the lights a little bit more? Yes, you will. If you do that to heat trace, you're going to exhaust that heat trace a little bit quicker. But that's not what we're discussing, right? You're looking at a very slow thermal inertia. So there's no worries there at all. If you are trying to maintain a temperature, will the control scheme help you to maintain that temperature? Absolutely, yes. That's different than on-off control, right? So those are actually two separate issues. You are going to have on-off control. The heat trace is either on or the heat trace is off. You're not typically going to have proportional control with trace just because it's not, the thermal system isn't that sensitive. So you might have, if you know PID control, you might have P, but you're not going to have the I and the D. So essentially it's on off. But the heat trace doesn't know that you're trying to maintain 150 degrees or 170 degrees. It doesn't know that. It's self-regulating, but self-regulating doesn't mean self-regulating to 170. It just means it's the resistance of the cable is going to fluctuate with response to temperature. So if you have an RTD in your bundle or on your line somewhere, that RTD goes into the panel says 170 because that's what it's programmed to. Now you're going to maintain 170 degrees. If your plant goes down and you want to turn off the heat trace because the plant's going down, then that's a set point that you would just adjust in there. And that's a really common thing with alarms is the plant goes down or you put part of it out for an outage and then everything gets cold, the heat trace is like firing and you're getting alarms all over the place and people go, well, yeah, it's an outage. And what they don't realize is one of those is a GFI trip. And then they bring the plant back online. Well, nobody went to the panel and clicked the GFI trip, and now your heat trace is off. And that's one of the major problems when people don't have a smart control system and they just start ignoring lights. So great questions. Did I? There you go. Okay. So just, yes, I'll grab you in 2 seconds. But so the difference between ambient control and line control, any thoughts? Okay, not to get too geeky, but it's a one-to-one versus a one-to-many relationship. So if you're doing ambient, you're going to have a sensor out there floating around wherever it is. And if it gets cold, all your heat trace turns on. Line sensing, you might have a couple of different lines, MI cable lines, process lines, right, that you're maintaining those at 150 or 170 degrees. You need sensors on those pipes uniquely, individually, so that you know those pipes are 170. And then these other pipes over here are all freeze protection. So those are conversations that we love to have because we can help optimize that design from a whole plant standpoint. Those are the really fun ones to have. Go ahead, please. No, we haven't seen data that indicates that's going to shorten life as long as it's not being, ramped up super fast and then brought down super fast. It's the rate of change is far more important than the rate of change is more important than the delta in T, for example, or the number of cycles. As long as you're doing it at a reasonable rate, which again, with the ramping capabilities on the panels is no problem at all. I'll do this all day. I love controls. Anything else? Please. Yep. So yeah, you just queued up my friend. So yeah, he's got your back. Yep. It's a great question. It really is. And probably on that, we'll just transition right into you, John. You need this. It's really important.
Yep. Thank you. Going into this is actually part accessories and so forth, which is part of your RTD question. Oh, wrong way. All right. We're going to get into this insulation part first, then we'll get into that part of it. Again, yesterday, it was mentioned about the number one cause of failure of bundles is typically installations. I mean, we've seen everything in this business, especially CEMS bundles. Excuse me. And the biggest problem I've ever seen is people installing that never installed them before, and they stretch the bundles. One of the benefits of how we build our bundles, we spin them, it helps keep the core of that bundle together in one piece. And if you guys that are using stainless steel tubes, what happens to that stainless steel when you get it up 375 degrees or whatever? It expands. What's happening to that heater cable if it's expanding? Exactly. Where's it going? The way we build it, we wrap that cable around it. It will twist with the bundle as it stretches, and it won't damage it. I've seen bundles pulled in half before. We had one in Georgia that they installed, they tied on the end of it. It was 375 feet long. It stretched the outer jacket that far. It pulled wires apart inside the bundle. I was able to fix it, but we couldn't guarantee it's going to last. That's the problem. But anyway, installation is the number one cause. If it's done right, it'll last for years, and y'all know that. And some more, more stuff here. They installed high temp inseal kit. These are high temperature lines off a drum, and they're not sealed. What's going to happen? Moisture's going to get in them. They're going to be gone in 6 months. We have a very detailed installation instruction sheet that we put together several years ago after I started. And if you follow these procedures, you won't have any issues. There's always something that comes up. Thermon does have a construction group in Houston. We are a full turnkey solution company. We engineer it, we design it, we build it. We have a company in Houston that can install it for you. And if for some reason, not all the times it's feasible for us to come out. So we will work with a local contractor that y'all like, that works on site. We will train them. We can oversee the construction and install. Then we also can offer an extra warranty to go with that. Typically it's a year. This is just a, typical with your RTD, and that we're going to get into that. The second problem we see more than anything is the people install the bundle backwards. And what do they do at the probe? They cut it off. What happens? All your RTDs were up there. So now you don't have any RTD fees. So what do? We actually have, I'm gonna see if I can find that. Well, let me back up. This is just some more improper installs and people wonder why their stuff doesn't live. This one over here basically got water in it and there's nothing left. This is a group in Chesterfield, Virginia that we did I overseen the install on it. He's a union contractor. We did 5 bundles in 2 days. Up, installed, strapped, in the shelter, terminated, ready to go. These guys, we sent them the details. I went out a day early. We went through it. They laid their bundle out on the ground. They set plywood down. Yeah, we use Kellum grips on ours, but we don't install them the way that O'Brien does. We crimp ours together. They're solid one piece. You slide all of them on you need, and we recommend every 35 feet. Because your typical CEM bundle, 3.5 inch OD, they're heavy. They're real heavy. So we did a test at Thermon on how much weight those Kellums will hold. 35 feet is the number we come up with to secure it properly. And again, they set them all on there. They rolled it out. They marked 35 feet on the plywood. When they got to that point, they cut another one loose, strapped it to the rope, and then they secured it in between. It was just like clockwork. We never stopped. The bundle never stopped rolling. They use duct tape to secure the rope in between the Kellums, and then they use nuclear tie wraps also. And then when they went back and installed it, they just cut the duct tape off, they cut the tie wraps off, they strapped the Kellums to the stack, and then they went every 5 feet between and secured it. That was the end. They just wrapped up all the unheated section that was out and wrapped it with a plastic wrap to keep it from getting damaged. This is some of the pictures. Stuck. There it is. The analyzer shelter on this plant was 150 feet in the air up on the top floor of their building. So it's a lot of high work. All right, getting back to, going back into our design stuff, this is some of the services that we offer. We actually have an audit team that works with the construction group in Houston that we can come out and do a complete audit on your heat trace system. It doesn't matter what it is. If it's got heat trace in it, they can audit it. And then we give you a full report on what they find. It covers everything, controls, heater cable, anything and everything. And then you come back, all right, well, this is what we got. This is what we, what's it going to take to get it done? We can also give you a price to come in and fix it also. All right, this is some of this new company we just bought, Power Blanket. They're located in Salt Lake City. I didn't know a whole lot about them until we bought them, but I love them. I mean, there's a lot of applications. Everything's custom built, and most of the turnaround time on these for tanks and so forth is like a week to 2 weeks. And they're heated. Your gas cylinders. The higher the temperature, the higher the pressure. And what we've heard is they were changing tanks that they thought were empty, but they wasn't. So these blankets heat them up and keep the pressure up, and therefore they get more life out of their tanks. That's what we were told. Velcro straps, yeah, however you want it. Most of them have Velcro down, and then they have either 1 or 2 straps. You can add whatever you want to them. All right, there's not one on here, but we have a complete accessories kits for all of our bundles. 90s. If you got to make a splice in a bundle, we have that kit. We have an RTD complete kit. And what happens is people cut their RTDs out and then they freak out. It's simple. Well, you can buy this kit. You can do it, or I can come out and do it. We'll open up the bundle down to the tube, insert an RTD. Our kits are a composite material, 2-piece clamshell that's got an O-ring in it. You cut it off at the size of the bundle, put your RTD in it. And there's a Myers hub and a junction box that has lugs in it that mounts on top. You put those 2 clamshells together, open up that, run a conduit back to your controller. You're good to go. So you can, if you want to add another RTD, you can do it that way too. You can shove it up in the RTD, your spare tube as well. Yeah. And one thing else I want to add on our HPT cable, our nodes, you can feel them. We notch that tube depending on the wattage, like our 20 watt cable is 24 inches. So every 24 inches, you're going to have a node on this side and then one on this side, 24 inches apart. So you don't have to ohm or nothing. You just take your hand and run it down the here cable. You'll feel it. Well, then at that point, you measure back 24 inches. That's where your next one's going to be. And then so forth, all the way down the line. And then when you make your cuts, you cut 6 inches above that node. That way it's hot. The rest of the bundle's hot all the way. Because if you cut within that or right behind that node, that 20 inches is going to be cold. So that's the only thing really you need to worry about. Yes, sir. Yep. It's round and it's more efficient. Correct. Yep. Yeah. Yeah. We do everything in San Marcos. If you follow what we recommend with the Kellum grips, and then one thing that I didn't like about his comments yesterday about the electrical conduit clamps. My background is electrician. I was an electrician for 30 years before I retired. And I had my own company, and every electric conduit clamp will not fit every tube bundle. I don't care. We have a solution for that. Is I'll wrap that bundle with our FAK self-vulcanizing tape. It's cheap. Guess what? You can build it up. You give extra protection to that bundle to keep it from crimping it or cutting it. I mean, it doesn't take a rocket scientist to figure out. If it doesn't fit, you make it fit. And that's the one. Now, we have a new clamp that I'm testing that I found at PowerGen. It's a composite material, and it opens up like this, and it clamps and it snaps. And from what I've been told, they're super durable and they're UV resistant. But I mean, you just mount them on the strut, you pull it apart, put your bundle in it, and you just squeeze them together. No, you need a screwdriver to take it apart. Just pop it loose. Good to go. Hopefully I can get that tested and on the market in a year. But if you follow that and you do those procedures we talked about, a lot of people don't like using tie wraps. I really don't like them, but if you're going to use them, X them and use the biggest one you can get and get nuclear grade. Nuclear grade, they last a lot longer than your typical plastic ones. And they have metal tabs in them that will grab. Anything else? Yep. Good question. Depends on the size of the bottle too, but your tip,
I sold them in my previous life, but I haven't yet. So, I mean, you're talking in the hundreds, not in the thousands.
yeah, just go on the website right now, Power Blanket, and it'll pop up. And actually, we have a link, I think, on our Thermon website as well. Yeah, and if not, get one of our cards. We'll help you out. We'll get you in touch with the right person. And we also have instrument heaters also. Same thing, instrument covers. Anybody needs a card, got any questions, whatever, come up and get one. We'd love to help you guys out if y'all got any issues. All right. Thank y'all.